Hello everyone! This video will go over our lab processes conducted in the PHG office both before and after the monitoring site visits. Because participation in these processes is optional, this video is only necessary to watch if you intend to come early to the office for the pre-field work and/or stay after we return to complete the post-field work. Both processes usually take about 30 minutes each. The pre-field work mainly involves calibration of the monitoring tools to make sure they're working properly and the titration of the dissolved oxygen measurement solutions. The thermometer that we use for taking the air and water temperature measurements don't need to be calibrated. There is also no calibration necessary for the nitrate and phosphate tests. For pH, we'll be using a probe, and that probe needs to be calibrated before each monitoring day. pH can vary depending on landscape, bedrock type, and a few other factors. In our region, we find the pH to be at or above 7, so to calibrate the probe, we'll be using buffers of pH 7 and pH 10. If the pH tends to be lower than 7, then the second standard to calibrate the meter to is pH 4. To calibrate the probe, we want to pour 50 milliliters of water into the small beaker and cut open the little pillows. We pour those into the beakers, one for pH 7 and one for pH 10. Stir with a clean stirring stick and place the probe in each solution to calibrate it. I'll now play this video for a visual example of the process.
This video will cover how to calibrate and use the new version of the Oakton pH30 tester, which has 3 vertical buttons on the front of the meter. If you're using the old meter with the buttons that form a triangle, use the video labeled Older Meter on the River Trends resource page. So the process is the same as the older meter, but the buttons are slightly different. You will need your pH meter, your pillow packets that bracket your normal reading mixed into 50 milliliters of room temperature water, and a cup of water or your squeeze bottle to rinse off your probe. If you haven't used your meter in a few months or the bulb appears cloudy or dry, soak your pH meter in Buffer 4 solution for about 30 minutes to rehydrate it before use. So today we are using Buffer 4 and Buffer 7 to calibrate. 4 is in red and 7 is in yellow. Make sure that you use the solutions that bracket your normal reading when you calibrate. We will be using the long press and the short press on the buttons today. A short press is a quick 1-second press, and a long press is holding the button down for about 2 seconds. So short press the power button to turn on your meter. You can short press this button again at any time to turn on the blue backlight on your screen if it helps you see. Always start with your Buffer 7 solution. Place your meter into the yellow cup and wait for the stabilization icon, which is the small smiley face, to appear. Once it appears, record your temperature, which is the bottom number on your datasheet. The top number is what your meter is currently reading. This will most likely be very close to 7, but not exact. Long press CAL, which is the bottom button, until your screen flashes CAL in green, and allow the stabilization icon to return. The bottom number should now read 7 when the meter recognizes which solution it is in. Short press CAL to enter this as your calibration. Record the number that flashes on your screen after you press CAL. The meter will now return into measurement mode. Take out your meter, rinse it thoroughly with water, and repeat this process in your next calibration solution. Place your meter into Buffer 4 solution, long press CAL to enter calibration mode, and wait for the stabilization icon to appear. Short press CAL to save your calibration. Record the number that flashes on your datasheet. If you used Buffer 4 and 7 solution, you will see an L and M icon for low and middle in the lower left corner of your screen. If you use 7 and 10, you will see an M and H for middle and high. Turn off your probe by long pressing the power button, then rinse with water and replace the cap to take it into the field. When you are in the field, short press the power button to turn it on. Place your probe into the sample water and wait a few minutes for the stabilization icon to appear. Record the number on the top of your screen as your pH reading on your datasheet. When you return from the field, we want to ensure that no probe drift has occurred. So we'll check this by taking measurements of our calibration solutions. Turn on your meter and place it into buffer 7 solution. We are not entering calibrations here, just taking a reading. Allow the stabilization icon to appear, then record your temperature and pH reading on your datasheet. This number must be within 2/10 of your standard solution, so with buffer 7, this needs to be between 6.8 and 7.2. If your reading is outside of this range, contact your coordinator for help resolving the issue. Repeat this exact same process for your second calibration solution. If your pH field reading was not within the calibration values that you used, perform a post-sample check with all 3 buffer solutions. Store your meter using either electrode storage solution if it's part of your monitoring kit, or pour a small amount of buffer 4 solution onto a small piece of paper towel to be stored at the bottom of your cap.
Next, for the pre-field work, we will need to calibrate the conductivity probe. I'll play another instructional video to demonstrate.
So the first thing that we're going to do is we're going to pour 30 milliliters of the conductivity standard into the speaker right here. So here is just the 30 milliliters of the conductivity standard, and next we're just going to put the probe into the standard. So right here you can see this is the probe that we're going to be using. So the first thing we want to do is just turn it on. So just press the power button. And then we're just going to hit mode to make sure it says conductivity. It already does, but just in case it didn't, you would just hit mode until it says conductivity right there at the top. And then what you're going to do is just place the probe into this solution right here, the conductivity solution. And you're just going to wait for it to stabilize. And that's when the smiley face comes up, so you can see it's stabilized right now. And then so once it's stabilized, you're going to long press on cal. Then the bottom number is going to read 1413. And then you're just going to wait for the smiley face to appear again, which you can see it already has. And then you're going to short press on cal. And then there you go, you're just going to record that number that just popped up on our data sheet, and we are good to go.
Similar to the pH solutions, we're going to save the conductivity standard that we used for the post-field work we will be doing. The 1413 number is the conductivity of the solution that we're using to calibrate our meter to read. To measure dissolved oxygen, we'll be using the Winkler titration method, which uses all the materials listed here on the screen. Before going into the field, we need to check the sodium thiosulfate because it is unstable and it can degrade suddenly, so it needs to be checked before each sampling period. Here's a video demonstrating how to complete the pre-field sodium thiosulfate check.
Your sodium thiosulfate must be checked to be functional before each sampling event. To get started, take off the cap of your titration tube and rinse your titrating tube with about 5 mL of your iodate iodide standard solution. Quickly replace all caps when not in use. Rinse the inside of the container, making sure to cover the entire titration tube and empty into your waste container or down the sink. Pour 20 mL of iodate iodide standard into the titration tube. Rest the tube on a table and get down to eye level to make sure the bottom of the meniscus or curve is on top of the 20 ml line. Use the eyedropper to remove any excess down the drain, never back into the brown bottle. Add 8 drops of sulfuric acid. Whenever you add drops, be sure to hold the bottle completely vertical to ensure an equal drop size. Recap your sulfuric acid, put the cap back on your titration tube, and gently mix by swirling. Once your titrator is properly filled with 10 ml of sodium thiosulfate, we are ready to begin our titration. To know that the sodium thiosulfate is functioning properly, our result for our iodate iodide standard should be between 9.4 and 10 milligrams per liter. To begin, place your titrator in the cap and add a few drops of sodium thiosulfate, then gently swirl the mixture. Continue this process until you reach a pale yellow color. It helps to have your titration tube against a white background. Remove the cap, leaving the titrator in place. Add 8 drops of starch solution, holding the bottle completely vertical. Replace the cap and gently swirl to mix a uniform color. Continue your titration process, adding a couple drops at a time, then swirling gently until you have reached a uniform light blue color. When you have reached light blue, add 1 drop at a time and mix well. It will take just 1 drop to turn the solution completely clear. Once the solution has turned clear, stop titration and read the results on your titrator. Here we can see that our result is 9.6 milligrams per liter, so we know our sodium thiosulfate is functional. Record this result on your datasheet and proceed with collecting your sample. Perform a second test only if the result is less than 9.4 or greater than 10. Record this result on your datasheet marked second check. If the second check is also out of range, contact your coordinator to obtain new sodium thiosulfate and do not take your DO sample for the day. If the second test is within range, record this result on your datasheet and perform a third check to confirm. If the third check is within range, you can collect your sample. Use this same titration method on your sample water after it has been fixed in the field to determine the dissolved oxygen content. Remember, adding sulfuric acid is part of fixing your sample in the field, so do not add sulfuric acid into the titration tube when you are testing your sample water.
The post-field work involves measuring the dissolved oxygen levels of our water samples, as shown in this photo. To measure the dissolved oxygen levels of our water samples, we'll use the same titration method that we used to test the sodium thiosulfate before the fieldwork. To do this, we want to pour 20 milliliters of the fixed solution into the titration tube, and then you want to fill the titrator with sodium thiosulfate to the 0 mark. Then you add drops of solution until it turns pale yellow. Then you take off the cap and add 8 drops of the starch solution, and this will turn it dark blue. You will then continue adding drops of sodium thiosulfate until it turns clear, 1 drop at a time, because 1 drop can change it to the color you need. If the solution is still blue when the titrator reaches 10, you want to stop and refill the syringe to the 0 line with sodium thiosulfate and continue titrating until the solution is clear. You would need to add 10 milligrams per liter to the final reading, and then you record the total number on the data sheet. The post-field work for pH checks to make sure the probe maintained proper calibration during the field sampling. To check, rinse the probe with clean water and dry off with a cloth. Then place the probe in the pH 7 buffer solution from before, allow the probe to stabilize, and then record the reading on the data sheet. Rinse and repeat for the 4 or the 10 buffer solution, depending on our sample results. What I mean by that is, for instance, if we go into the field and get a pH of 6, the next time we calibrate the probe, we're going to use the 4 and 7 buffer solution to calibrate it rather than the 10. But if we go into the field and we get a pH of 9, then we would use the 7 and 10 buffer solutions to calibrate the probe. The post-sample check needs to be within 0.2 units from the buffer value. For instance, for the pH 7 solution, the post-sample check needs to be within 6.8 and 7.2. If it is between these numbers, that indicates it maintained proper calibration within the field, and we can use the pH data that we got. To summarize, the pre-field work at the office would involve testing the sodium thiosulfate for dissolved oxygen and calibrating the probes for pH and conductivity. Once we're in the field, we'll be monitoring bacteria, temperature, dissolved oxygen, pH, conductivity, nitrite, phosphate, and water clarity. If you choose to come back to the office to help with the post-field work, you would be checking the dissolved oxygen levels and checking to make sure the probes maintain proper calibration for pH and conductivity. We want to give volunteers the option to help with this pre- and post-field work because oftentimes in the field things move very quickly, like for instance with the pH and the conductivity. And we want to provide the opportunity for you to learn as much as possible. Thank you for tuning in.